Okay, so this lesson's for week 8, lesson 7, and it's taking a factoring method that you already know and are quite comfortable with and kind of building on it. Okay, so we're going to start with one form, which is the quadratic form, right? So you've factored literally hundreds of expressions that are trinomials, right? And they look like this, but a couple things you may not have noticed about them is this exponent right here on the x is a 1, and this one is a 2, and this is always half, right? If I take the 1 and I double it, I get 2. Okay, and I know that seems kind of weird to even bring up, but it's going to become important in just a second. All right, so if you take a look at this example where I have x squared minus 17x plus 16, if I asked you to factor that, you could do that without almost even thinking. You're looking for numbers that multiply to be positive 16, that add up to be negative 17, and you would say, hey, that's x minus 16, and that's x minus 1. No big deal. But what I really want you to notice, and you may not have ever picked up on this before, is that this exponent is a 1, this exponent is a 1, and this exponent is a 1. All right? So now what happens if I take away these things that I wrote on here to cover up my problem? All right? Because the problem isn't really as simple as you thought it was. Now there's a 4 in there and a 2 in there. All right? But what I'd like you to really, really notice is that this is half of that, right? Or if I multiplied 2 times 2, I would get 4. And the factoring, like the numbers over here still work, right? This negative 16 and this negative 1 still work. What I need to change is this 1 and that 1 aren't supposed to be 1s. They are supposed to be, for this problem, it's weird, that other part won't erase. Anyway, for this problem, because this is a 2, these will be 2s. Okay. Another way to sort of think about this is you could rewrite this problem like this. Where, and I'll highlight it for you, the stuff inside the parentheses is what you have over here. Right? Everything that's in the parentheses is an x squared. Over here in the factored side, those are also x squares. All right, and you can kind of see how this lines up with what's written down here. I've got something squared, and then minus 17 times that exact same something plus 16. Okay, so let's move this up. Let's try another one. Okay, and I know it looks really kind of strange, but if, and let me see if I can find a way to cover this up. If this wasn't a 1/2, if it was just a 2, couldn't match the shape. Sorry, my program here is acting odd, and I'm not sure why. Let's try this. Here. Nope, still won't do it. How about that? Okay. Sorry for the delay. I'm sorry about this. Let's try this. If this was just x squared and this was just plain old x, right? If those weren't there, if it was just a simple factoring problem, every one of you would say this is x minus 3 and x minus 5. Okay? You know how to factor a trinomial. That's not the point of this lesson. The point of this lesson is to show you that it works also when these numbers are different. So as long as this number times 2 equals that number, then down here I can label this with the appropriate exponent. Okay, that's the only condition, is that this exponent has to be half of this one. Okay, let's try another. All right, so let's take a look. This exponent is half of that one, right? If we multiply by 2, you would get 4/3. So I should be able to factor it the same way that I factor any other trinomial. I'm looking for numbers that multiply to be 36, but add up to be negative 13, which is negative 4 and negative 9. I don't know if you guys just heard that. That was my pit bull snoring right next to me. Anyway, here I'm going to have x to the 2/3, and here I will have x to the 2/3. All right, so then let's scoot it up. Now you've already learned how to factor a difference of cubes and a sum of cubes, but there's other numbers that are perfect cubes besides just a 3, right? X to the 6th is a cube because it's x squared cubed, the same way that this is 3 cubed. So when you're filling in, right, you have a binomial and then you've got this trinomial, and you know that the signs are supposed to be the same sign, the opposite sign, and always positive. Okay, but instead of just having an x here in this first blank, you're just going to have an x squared. All right, and here, instead of it just being x squared, you got to take that first number and square it. This will be x to the 4th. All right, and this will be 3x squared, and this last one will be a 9. All right, all you have to do is remember that this number is still a cube, and if you can write it as a cube, then you know what goes in that first blank. And again, once you know what's in that first blank, you kind of know what goes everywhere else.